Chapter 4, Section 4.7, Inverse Trig Functions. In these notes, I will be referencing your inverse unit circle, so make sure that you have that either memorized or handy. Let's start by talking a little bit about inverse functions. So example 1 on here, I have find sine of pi over 6. We know that the y-coordinate at pi over 6 is 1/2. Part 2 says, find my angle theta if sine of theta equals 1/2. So what we're doing is we're saying, what angle do I have a y value of 1/2 on the unit circle? So the way that we can write this is sine inverse of 1/2. That's what that little -1 means, sine inverse. Or we could also write it as arc sine of 1/2. They mean the same thing. They both say, what angle has a sine value of 1/2? Let's look at this graphically for a minute. In blue, you can see I've graphed y equals sine of x. It goes on forever to the left and the right. If we were to find the inverse of this blue graph, remember to find inverses, we just reflect the points across that line y equals x, so we switch the x and the y values. But if we were to find the inverse, we would get something like this. This is a sinusoidal function, but it's going up and down, which means it's actually not a function because it doesn't pass the vertical line test. So in order to fix that, we are just going to restrict our sine function, the blue function that we see, to stay between -pi/2 and pi/2. So that the inverse function, the red function that we get, is still a function. So both the blue and the red graphs cross my vertical line test here. Now that we've restricted these functions, it's going to be a good thing to write down their domain and range. So my sine function in blue at the bottom, I've written that the domain is from -pi/2 to pi/2, and my range is from -1 to 1. To get the domain and the range of the sine inverse function, I'm just going to flip those. So now my domain is -1 to 1, and my range is -pi/2 to pi/2. The domain of my sine inverse function tells me the only numbers that I can plug in to sine inverse will be between -1 and 1. So if you're asked to find sine inverse of 5, you can't do that. It's not defined because 5 is not in the domain. Likewise, we need to point out that our output, the answers we're going to have whenever we take sine inverse of something, is always going to be between -pi/2 and pi/2. So if you look at your inverse unit circle, that's just quadrants 1 and quadrants 4. It's really important to note that sine inverse output is always going to come from either quadrant 1 or quadrant 4. You will not talk about inverse of sine in quadrants 2 or 3. Example 1, we're going to find the value of sine inverse of square root 3/2. So on our inverse unit circle, we're looking for where y equals square root 3/2, either in quadrant 1 or 4, and that happens at pi/3. Example 2, find sine inverse of negative square root 2/2. So we're looking for where y is equal to negative square root 2/2, either in quadrants 1 or 4, and that happens at -pi/4. Next, we're looking at the inverse cosine function. Just like the sine function, if we were to find the inverse of cosine, it would not be a function because it would not pass the vertical line test. So we're going to restrict cosine to just be between 0 and pi. That means cosine inverse will have a restriction on what it can equal that will just be between 0 and pi. So we're going to look at just quadrants 1 and 2 whenever we talk about cosine inverse. Example 3, find cosine inverse of -1/2. So we need to look and see where x equals -1/2 in either quadrants 1 or 2, and that happens at 2pi/3. Now we're looking at the inverse of tangent. So likewise, we have to restrict our domain of tangent so that we have a function whenever we find the inverse. So the inverse of tangent, our answers are only going to lie in quadrants 1 or 4 due to that restriction. So tangent and sine both use quadrants 1 and 4. Cosine's the only one that uses quadrants 1 and 2. Example 5, find tangent inverse of -1. So we're looking for where y divided by x is equal to -1, either in quadrant 1 or 4. And that happens at -pi/4 because my x and y values are the same, just a different sign. Example 6, find tangent inverse of √3. So we need to find where y divided by x equals √3 in quadrants 1 or 4. That happens at pi/3 because if we take √3/2 divided by 1/2, we're going to end up with √3. In example 7, we're going to use calculators to evaluate inverse trig functions. So on your calculator, you should see somewhere that says cosine inverse, so cosine to the -1. On my calculator, for example, it's the same button as cosine, I just have to hit second first. So on my calculator, I hit second cosine, and then I put 1/3 in there. Same thing with tangent. I hit second tangent, and I put -35.85 in there. Evaluate these two in your calculator and write your answer to 4 decimal places. Restart the video to see my answers. For the first one, I got 1.2310, and for the second one, I got -1.5429. Next, we're going to look at composition of trig functions. So remember, composition is just where we take one function and we plug it into another function. Here's some special cases for sine, cosine, and tangent. So looking at the sine section, if we have sine of sine inverse, we're just going to get whatever value is in that x spot for any x value between -1 and 1. So if we're on that interval, we just get whatever x equaled. Same thing with sine inverse of sine of x. As long as x is in between -pi/2 and pi/2, we just get that value back out. Same idea with cosine and tangent. If the x value in the parentheses is not in the interval that's listed next to each of these, then we'll have to think about our unit circle and our inverse unit circle and evaluate that way. In example 8, we're going to practice that. So for A, we have cosine inverse of 0.07. If I look back to my last slide, 0.07 is in my interval that's allowed. It was -1 to 1. So my answer here is just going to be 0.7. For problem B, we have sine inverse of sine of pi. Pi is not in the interval of -pi/2, pi/2. So we're going to have to evaluate this a little differently. I'm going to start by just looking inside the parentheses and evaluating sine of pi. So if I think back to my unit circle at pi, my y value is 0. So that leaves me with sine inverse of 0. And if I think of where the angle 0 is on my inverse trig or unit circle, I know that the y value for that is also 0. So my answer here is just 0. For problem C, I see that my -1.2 is not in my domain for cosine inverse. So this problem is just going to have the answer of undefined.